Hello guys, welcome back to our channel. Today we are going to see how to make the Verilog code for the ALU. ALU is nothing but the arithmetic and the logical unit which can be used in the any microprocessor. The main operation of this ALU, arithmetic and the logical unit, is to perform the arithmetic and the logical operations, such as nothing but the arithmetic operations means addition, subtraction, multiplication, division, and in logical operations mean the logical and logical or and all the logical operations. So now we are now today we are going to construct an ALU using the Verilog code to we so that each code which can perform the any of the operations by giving a certain instruction. Something suppose I will give some instruction called add, then it will perform the addition operation between the two operands. In this way, we will construct the ALU code. Okay, so for that I am creating the module ALU. We require input, right? So input, I am taking a 2, so 2 is to 3, which is nothing but 3 bits. 3 bits means 2 power 3, 8 combinations. So we can perform 8, we can give up to 8 instructions to perform the 8 different operations using this code, right? So for this, I am giving as a select. Okay, we require inputs, right? I will take 2 inputs, which is each of size 8 bit. So 6 is to 0, A comma B. Now output I will take as output is also 6 is to 0, and I am taking the R and closing this. Now I will use the behavioral model to design this ALU. So for that I am using the always command, always at the rate. Here I am giving the asterisk symbol. Okay, this asterisk symbol is nothing but here in this we have the three inputs, right? A comma B comma C, A comma B comma select. Out of three inputs, if any of the input receives the value from the user or the external environment, then the program will be start executing. It does not depend on a specific variable, it will be depend on the any of the variable. So for that purpose we will use this asterisk symbol in the code. So always at the rate asterisk begin. Now we'll use the case statement. So majorly on which item it will be most dependent select line, right? So select, I will start giving the values 3b000. That means if the input is all zeros, then what will be the operation will be done? R equal to A plus B. Okay, or one operation will be done. Now 3b001, here operation will be R equal to A minus B. Now 3b00, sorry, 010, which is the 2 are equal to A multiply B. Now 3 b0 011, here R equal to A divided by B. Next 3b, and what are the other possible combinations? 3 100. I'm just writing all the sequences which will be possible. 3110 bb111. Okay, here I will write the operations. Now we can write a ampersand b, which is nothing but the logical operation, logical and operation. Now here r equal to a and b, r equal to here r equal to a or b. Here r equal to a, not a. Now r equal to some complement b. Here we can you can write any of the logical operations which can be performed, and I am using some default. So if we does not give any of the inputs, then the default operation will be done. Here I am just giving r equal to 0. If I didn't give any output, then the output will be printed as a 0. So here I am closing this case statement. I am closing end the always block, and I am closing the end module. I mean that means I'm stopping the design code, which is nothing but this is the design code for our ALU using the behavioral modeling. Now I am going to write the testament module TB. What are the inputs registered? 2 is to 0, select, and other inputs are or 6 is to 0 with nothing but the 8 bit, right? Each a comma b, and we have only one output which is the size of 8 bits, 6 is to 0, and r is the result. Now I am extracting all the inputs and the outputs from the design code. What are the inputs and outputs? Select a comma b comma, and other is nothing but the result. I am going to set initial, begin. I am writing some command called monitor which can be display the result at the console. Here I will display select line. What are the input? A equal to percentage b, and next b equal to percentage b, and r equal to percentage b. R is nothing but the result, right? So here I will write select comma a comma b comma r, right? Now I will start giving the values. Here first I will give the opcode is equal to some 000, the 3 bit, right? So 3 b, here a equal to some 5 and b equal to 3, and I am giving some time delay. Okay, sorry, here we are select, right? Select 3 bb001. Here again I am giving a equal to 5, b equal to 3, and giving some time delay. Now I will does not give the any select line. I will just give the inputs and the outputs, and here in this case also we will see what will be the output. B equal to 3 and some time delay. Now I am stopping this module, dollar finish. I am ending this and end module. So this is the testament required for our ALU. Let's verify whether it is working or not. So I'm selecting the tools on the simulator, accuracy 0.9.7, and I'm saving this file, and I'm going to run this. Here I am giving the name as ALU, and I am again will be save, and I will again run this. And there is something error called. Here we are facing at the which error 12th line, and here we are getting the some syntax error at the 12th and 13th line. Let's see whether what are this. See, here we have give the wrong syntax, and here also. Now let's verify whether it is not correct or not. I'm just running this. Here we get this again some error code or is not valid. Here you can see we not declared here output register. In behavior model we have to definitely mention the output as a register, because in the behavior model the output will be act as a register in memory which can store the outputs. So we will use the output register, and again here I just removing this syntax so that the default case will be work good. That means here I will give the select line as some out of the instructions, select equal to 3b111. So according to our conditions, here there is no 111, right? So according to the default condition we will get the output as a 0. So let's verify all these are correct or not by running this program. As we got the output for the first thing, Here 000 means we are nothing but we have to perform the addition operation. Here 5 plus 3 equal to 8. In the binary representation, the binary representation, the out 1 triple 0. This is nothing but the binary representation. And second one is the subtraction operation. Here 5 minus 3 is 2, so 0 1 0. Yes, we got this. And for the 3, which is out of the case statements, so default statement is executed and the output is 0. So in this way the ALU is worked. Thank you for watching this video. If you have any doubts, please mention in the comment section. You can get this code through GitHub, which is provided in the description. Thank you for watching this video. Stay tuned for the next one.